ये वीडियो लेक्चर में हम समर 2022 के इनफाइनाइट सीरीज के सम सॉल्व करेंगे। क्वेश्चन 1A इज summation 1 upon n raised to p convergent for p greater than 1, justify your answer। मतलब कि ये क्या है, दिस वन इज अ p सीरीज। अब p सीरीज का कन्वर्जेंस क्या है वो हमें ऑलरेडी पता है। दिस इज द p सीरीज एंड दिस सीरीज इज कन्वर्जेंट फॉर p ग्रेटर देन 1 एंड दिस सीरीज इज डाइवर्जेंट फॉर p लेस देन और इक्वल टू 1। ओके, मतलब ये कंडीशन हमें ऑलरेडी पता है, लेकिन हमें यहाँ पे क्या करना है, हमें ये कंडीशन जो है वो हमें क्या करना है, यहाँ पे प्रूव करना है। ओके, तो अब इसका हम आंसर कैसे देंगे। ओके, तो इसके लिए हमें यूज करना है यहाँ पे कॉशी इंटीग्रल टेस्ट। Okay, so now let's first discuss what is the Cauchy integral test. Cauchy integral test, ये टेस्ट में हमें क्या करना है, इसका यूज करके हमें एक जो सीरीज UN दी है, ये सीरीज का हम क्या करेंगे, कन्वर्जेंस चेक करेंगे। ओके, तो ये टेस्ट में हम क्या कर रहे हैं, लेट्स सी। If fx is positive, continuous and decreasing for x greater than or equal to 1 and un is equal to fn, then the series un and the improper integration from 1 to infinity fx dx either both converge or both diverge। मतलब कि ये टेस्ट में हम क्या कर रहे हैं, हमारे पास एक सीरीज un है। ओके, now take un is equal to fn, means nth number of term of series is same as one function fn। अब ये फंक्शन क्या कर रहा है, this function satisfies some properties। this function is positive, continuous and decreasing for x greater than or equal to 1। अगर ये फंक्शन ये तीनों प्रॉपर्टी सेटिस्फाई कर रहा है, ओके, then we write it in this form। ओके, इंटीग्रेशन फ्रॉम 1 टू इंफिनिटी fx dx, और हमें क्या करना है, ये इंटीग्रेशन फाइंड करना है। अगर ये इंटीग्रेशन क्या है, दिस वन इज फाइनाइट, देन व्हाट वी कंक्लूड, दिस इंटीग्रल एंड दिस सीरीज बोथ कन्वर्ज। इफ दिस इंटीग्रल वैल्यू इज आइदर प्लस इंफिनिटी और minus infinity, then what we conclude, this integral and this series both diverge। ओके, मतलब कि हम ये फंक्शन के इंटीग्रेशन के बेस पे सीरीज का कन्वर्जेंस क्या कर रहे हैं, चेक कर रहे हैं। सो दैट्स व्हाई दिस इज नोन एज इंटीग्रल टेस्ट। नाउ इन दिस क्वेश्चन फर्स्ट कन्वर्ट दिस सीरीज इन अ फॉर्म ऑफ function and then find the integration of this function। okay, so now let's start. Here what is given, series given 1 upon n raised to p। now as per the integral test, an is equal to fn। okay, now here what is an, an is nth number of term of this series, so this one is what, this one is nothing but 1 upon n raised to p। okay, now write this fn in form of function fx। so now n is replaced by x, we get fx is 1 upon x raised to p। so now from this series, using nth number of term, find function fx। okay, so fx is what, this one is what, this is nothing but the nth number of term, but it is in form of x। okay, now let's check these three conditions, whether this function is positive, continuous and decreasing for p greater than 0 or not। okay, so now here p greater than 0 means here first fix p। suppose here I am taking p equal to 2, I am fixing the p। okay, Now first f of 1. So what is the value of f of 1? 1 upon 1 raised to 2. Find f of 2. So f of 2 is 1 upon 4. F of 3 is what? 1 upon 9. Okay, and so on. Now here see, for all value of x, here we get the positive answer. Say yes or no. Okay, all these are positive value. So that's why this function is what? Positive function. Again, for all value of x, we get the answer f of 1, f of 2, f of 3, as well as we can find f of 1.5, f of 2.9. Okay, matlab we can find function f for any x. Okay, so that's why this function is what? Continuous function. Okay. Third, here in denominator, see 1, 4, 9 and so on. So here denominator increases. Okay, so that's why the entire number what? Decreases. So as here x increases, f of x what? F of x decreases. Okay, so here these three conditions are satisfied. First of all, consider the function fx is equal to 1 upon x raised to p, where x greater than or equal to 1. Then fx is positive, continuous and decreasing for p greater than 0. From this discussion, so hence we apply the integral test. So now find the integration from 1 to infinity 1 upon x raised to p dx. मतलब कि अभी हमें क्या करना है, ये जो फंक्शन है इसका हमें इंटीग्रेशन फाइंड करना है. ओके, नाउ दिस वन इज द इम्प्रॉपर इंटीग्रल. से यस और नो. सो दैट्स व्हाई टू इवेल्युएट दिस इंटीग्रल use the concept of improper integral. So now let's start. Case 1, p is not equal to 1. Okay, now p is not equal to 1 means either p is greater than 1 or p is less than 1. तो अब हम ये दो केस के लिए ये इंटीग्रल वैल्यू चेक करेंगे. ओके, सो नाउ व्हाट इज गिवन? दिस वन इज अ इम्प्रॉपर इंटीग्रल. ओके, सो हाउ टू सॉल्व इट? टेक limit n tends to infinity, instead of n, here take t tends to infinity, integration from 1 to t. So first from here remove infinity. Okay, 1 upon x raised to p into dx. Now solve this integration. Here, what is the integration of x raised to n? So integration of x raised to n is x raised to n plus 1 upon n plus 1. Okay, so now use this formula. Here x raised to p. So can we write x raised to minus p in numerator? Okay, so now find the integration of this value. So we get x raised to minus p plus 1 upon minus p plus 1. And here lower limit is 1, upper limit is t. Okay, now replace this upper and lower limit. T, x is replaced by t raised to minus p plus 1 upon minus p plus 1. Minus, replace the lower limit. So x is replaced by 1. 1 raised to any number is 1. 1 upon minus p plus 1. Okay. Take first case p greater than 1. Okay. Now for p greater than 1, let's check what is the value of this limit. P greater than 1, suppose I assume that p equal to 3. Okay, now put here 3. So here what we get? Minus 3 plus 1. So this one is minus 2. So what we get? T raised to minus 2. Okay, so now t raised to minus 2 means we can write 1 upon t square. Okay, so now put this value in this limit. So we get limit t tends to infinity 1 upon t square into minus p plus 1 minus this term remain as it is minus p plus 1. Okay. Now apply limit. So 1 upon infinity become what? 0 minus infinity into this number is infinity. Okay. So 1 upon infinity becomes 0 minus this one is a finite number. So keep as it is 1 upon minus p plus 1. This number is free from t. Okay. So now take minus sign common. So we get 1 upon here p minus 1. Okay. So we get this answer. So the integral value of this function fx is some finite number. Here p is, here what I assume, p is 3. Okay, so 1 upon 3 minus 1 means what we get? 1 upon 2. Okay, so this is what? Some finite number. So that's why what we conclude, for p greater than 1 the integral is finite, and as per the integral test, if this integral is convergent, finite means it's convergent. Okay, so if this integral is convergent, then the series is what? Also convergent. Okay, so for p greater than 1 the given series is convergent series. Now let's check for p less than 1. Now p is less than 1, second case. So here I assume that suppose p equal to what? I am taking p equal to minus 2. Okay. So now put in this integral value. Limit t tends to infinity t raised to minus p plus 1 so now p equal to minus 2, so put here minus 2, so what we get? 2 plus 1 means 3, so we get t raised to 3. Okay, now put this value here, so we get limit t tends to infinity, here t raised to 3 upon minus p plus 1 minus 1 upon minus p plus 1. Okay, now apply limit. So here infinity raised to 3, infinity upon some finite number, we get infinity answer. Infinity minus again this one is some finite number. Okay, so what we get? Answer is infinity. Okay, so that's why what we conclude, this integral is what? Divergent. Okay, so if p less than 1, then value of this integral is what? Infinity. So that's why hence the integral is infinite. So from integral test what we conclude, this integral is divergent, and that's why the series is what? Also divergent. Okay, so what we conclude here, for p here greater than 1 the series is what? Convergent series, and if p is less than 1 then the series is divergent series. Okay, now take the second case for p equal to 1. Okay, now what is the function? Here 1 to infinity 1 upon x raised to p into dx. Okay, this is the given function. Now in this function put p equal to 1, so we get 1 to infinity 1 upon x into dx. Okay, now here take limit t tends to infinity 1 to t 1 upon x into dx. So use the concept of what? Improper integral. Now what is the integration of 1 upon x? This is the log x. Okay, lower limit is 1, upper limit is t. So what we get? Log t minus log 1. Okay, but log 1 is what? 0. This value becomes 0. Now put infinity, so log infinity. And what is the log infinity? Log infinity is nothing but infinity. Okay, so that's why what we conclude? For p equal to 1, this integral is what? Infinity. Okay, so that's why the given series is what? Divergent series as per the integral test. So here, this series 1 upon n raised to p, or this is the p series. P series converges if p greater than 1 and diverges if p less than or equal to 1. Okay.